the tree problem. A tree is growing. The first year, the tree trunk grows a trunk 2 meters long. The next year, 2 branches, each 1 meter long, grow at right angles to each other from the top of the trunk. They are symmetrical to the line of the trunk. In subsequent years, each branch will grow 2 new branches, each half as long as the preceding branch. Show that the lengths of the branches form a geometric sequence. A geometric sequence can be determined if any 2 subsequent terms can be divided into each other and still get the same number every time. Here, this is obviously the case. 1 divided by 2 is equal to 0.5. Similarly, 0.5 divided by 2 is equal to 0.25, which can be used to find another all value. However, down here you can see that 1 divided by 2 is 0.5, 0.5 divided by 1 is 0.5, and 0.25 divided by 5 is 0.5. Therefore, r is equal to 0.5. Find the height of the tree after 2 years, 3 years, and 4 years. You may do this problem manually. Although you were given the height of the tree in its first year, you need to find out how much it's grown vertically in the second. For this, you may use the 45-45-90 triangle. 1 equals x rad 2. In order to isolate the x, you can divide by 1 by rad 2. By multiplying both the top and the bottom of this fraction by rad 2, you will find that x equals rad 2 divided by 2. So you can calculate the height of the tree over the years simply by adding its growth for each respective year. For 2 years, you need to add 2 and rad 2 over 2 to equal 2.707 meters. For 3 years, however, it gets slightly more difficult. You must find the length of the third branch in order to calculate the total height. Since r is equal to 0.5, you multiply 1 by 0.5 to get 0.5, the length of the branch grown in the third year. Therefore, you need to add 2 rad 2 over 2 and 1/2 to equal 3.207 meters. Here, it is apparent that 1 times 0.5 is equal to 0.5. Therefore, the length of the second vertical branch. For 4 years, you can calculate the length of the fourth branch by multiplying rad 2 over 2 by 0.5, which equals rad 2 over 8. If you add 2 rad 2 over 2, 0.5, and rad 2 over 8 together, you will get 3.5607 meters, or the length of the tree after 4 years. Show that the height of the tree is the partial sum of 2 geometric series. What is the common ratio of each? Since the vertical heights occur every 2 years, you can multiply each odd year by 0.25, your r value, to get the next. You would need the equation for the partial sum of a geometric series. After 2 years of growth, there is only 1 yellow branch, and in this case is going to equal 1. Your equation will look like this, which n is going to equal 2 meters. After 3 years, your equation will look different. As opposed to having only 1 yellow branch, now you have 2. Therefore, your n value is 2, and your answer is 2.5 meters. After 4 years, 2 yellow branches still remain. Therefore, your equation will be the same as the preceding one. You can find the height of the green branches in a similar fashion using the same equation as well as the same r value. After 2 years of growth, there is only 1 green branch on the tree, so n equals 1. As we established earlier, the vertical height of this is rad 2 divided by 2. Then, you can plug all the numbers into the equation to get rad 2 over 2 as your final answer. For 3 years, you can use the same equation as the 2-year formula for green branches. The 4th year is different. There are now 2 green branches instead of 1, which means that n is now 2. This equals 0.884 meters. So, for year 2, you should add 2 and rad 2 over... For year 2, you should add 2 and rad 2 over 2 to equal 2.707 meters to get the total height. For 3 years, 2.5 plus rad 2 over 2 equals 3.207 meters. Finally, for year 4, 2.5 plus 0.884 equals 3.384 meters. Here. And as should have been quite apparent by now, your common ratio is 0.25. If the tree keeps growing like this forever, what limit will the height approach? For problems with a limit, you need to use the equation for the sum of an infinite geometric series, which is listed right here. You must solve the limits of the yellow and green branches separately. For the yellow branches, r is still equal to 0.25 and t1 is equal to 2. Your answer is 8/3 meters. You can find the limit of the green branches in the same way, except for the t1 in this case would equal rad 2 over 2 as opposed to simply 2. You should get 0.943 meters. Right there, it's very obvious that t1 is equal to rad 2 over 2. Your final answer is 8/3 plus 0.943, which is going to equal 3.610 meters. What limit will the width approach? In order to find this, you should use the equation for the sum of an infinite geometric series, which is shown in the top right corner. We can begin by finding the width of the green branches. R is equal to 0.25 and t1 is rad 2 over 2, as can be illustrated by the triangle. Your answer should be 0.943 meters when everything is plugged into the equation. You can find the width of the yellow branches in a similar fashion. However, you cannot begin with the trunk since it does not branch outwards. Therefore, you can divide 1 by 0.5 to get 0.5 meters. 0.5 is now your t1. The answer is 2/3 meters. Add the two limits and then multiply by 2 since there are two sides to get 3.219 meters. What limit will the length of each branch approach? Well, your r value is 0.5 and t1 is equal to 1. You can use this equation to find your answer. You can plug these numbers in to get an answer which equals 2 meters. What limit will the total length of all branches approach? The length of each branch is infinite. Although there is a limit to the height, the branches will continue to branch out and grow at a minuscule and hardly detectable rate. How close to the ground will the lowest branches come? For this problem, you will still use the same formula for the sum of an infinite geometric series in the top right corner. However, as is depicted in the circle, you must find the height of the first branch that slopes downwards. You can accomplish this by using the 45-45-90 triangle. By setting the length of the branch as 0.25 equal to x rad 2, you get rad 2 divided by 8, which is now your t1 for the green branches. You can plug this in to get 0.236 meters. You may calculate the t1 value by dividing 0.25 by 2 to get 0.125, which is now your t1 value. R is 0.25. Plug this into the equation and you'll get 0.167 meters. Your final answer should be 0.236 plus 0.167 equals 0.403, and 2 minus 0.403 is 1.597 meters.